Hello friends, today I'm going to talk about Leetcode 1218, longest arithmetic subsequence of given difference. The problem is that given an integer array and an integer difference, return the length of the longest subsequence. In that subsequence, every adjacent element, the difference equal to the given difference. Here, this is example 1. We have the array 1, 2, 3, 4, and the difference is 1, so we can get the subsequence that is 1, 2, 3, 4. Subsequence here is not a sub-array, which is not contiguous. And for others, we have difference 1. We cannot get this answer here. So each one is a minimum subsequence. So for this problem, that is, we can see that here we can say that there's first ideal, that is naive ideals. We can use 2 loops and with variables I and j to iterate this array. For example, we have this array 1, 2, 3, 5, and where the difference is 2 here, is here, and when we iterate I and j, we have to compare the I and j. The difference is where the difference is equal to the difference here. If it's not, we will not continue until we find the minimum subsequence. This method takes n square times. And the second method is that we can use dynamic programming here, because here is like a sub problem here. When we get the 1, 2, 3, and 5, and the sub problem is 2, 3, 5 is whether it is a subsequence, and then with the 3, 5 whether it is subsequence. We can say that it has the overlapping problem and also has optimal substructure here. So this is actually a very classic dynamic program here. We can define DPI is the number of the satisfied sequence up to index I from 0 here. So we can see that the DPI equal to the previous DPJ plus 1 if the array j if array j minus array I is equal to the difference, and for here there's the I is between the 1 and j inclusive. Here is like we have an array here, and currently this is the I, and for example here we have the j here. J is and we here is this is the j, and this is the I, and we can see that if the j and I has makes a difference, so the dpi would be the 1 plus dpj, right? For every element P is 1, and we can iterate the I from 1 to j to find the value of the dpi. In this way, if we write the function in the bottom up way, it also takes n square time complexities. Here we have found that we need to find whether the dp j and I whether equal to their difference equal to the given difference. So we can use the hash map to reduce the time complexities. We will check whether the difference is in the previous. If it's not, we will not need to update. So it's like that. We can see that dpi, whether if the whether the difference the difference is the value here, the value equal to array I minus the difference, and if the value is in the dictionary, that is in the dictionary, we can update. If it's not, we will not need to traverse from j to from 1 to j. This is the dictionary value, so in this we can reduce the time complexity to n time. Here, let's look at the how to write the code. So first we consider some corner case. If not, array is empty. Here we return 0, and we get the name of the array. We define a hash map to record each values. We can store the values as index. This k it should be the index. K should be the value, and the value should be the index. K should and then we initialize that the first element we define the dp as 1 because each element itself is a subsequence. Then we iterate this and we check whether the value is we want to find in a dictionary. If the value is in a dictionary, we will update the current as value here. So here we update, we get the index and plus 1 here. Then we update the dictionary, then we return the max dp here. So basically this is the idea. This should be take on time and on space here. Okay, we do not need to use here. Okay, let me try other test case. Good, we made it.